about the storage system. I believe this is so it's the fifth circle. So that is it corresponds to the river Styx, where the people who are too angry in life are sort of half drowning in it. And perhaps this symbolizes the mass of data that we have stored or are going to store on disk. And we must make sure not to drown in this. And that's what the storage system hopes to do. So I'm going to start with a short intro on this storage system. Then I have received 4 mysterious paths, so paths to files, and let's see if we can load the data in these paths together using the knowledge that you've heard from this intro and of course your reading last week. Then, as usual, we'll go to our questions and discussion on the code or on other things. I'll give a short preview of next week. Right, so the storage system. Why is it more complicated than, for example, in PAX? Right? In PAX, you had maybe supported 10 different file formats, and every file format had a certain input plugin and output plugin, and that basically was it. That was relatively simple because PAX didn't care about finding data. PAX, which is the Xenon 1-ton processor, just cared about making it or loading it once you give it the specific file name. Strax is a more integrated framework, which goes a little bit further and actually interfaces also with databases. It does some work towards tracking different data sets for you that previously was taken care of by hacks and by other packages. So Strax has more of a job to do. It has to find the data. So it has to find which data corresponds to your request, and it has to actually then load the data. So there's several agents involved in this. You have, of course, the context, which we've examined in the previous circles, which keeps a configuration that maps the incoming request that you make to a specific lineage, or as you've seen, a data key. So you just say, hey, I want Pete basics of this run. Then it says, okay, well, given this context that you have now, that corresponds to all of these settings. So that's the piece of data that you want. But that still doesn't mean you found it. That just tells you what you want. So the first actor you encounter in this stage is then the storage front end. And its job is to figure out where the data is. And it does that on its own. It doesn't go to any backend or, well, it may call, for example, if you have the run DB, it will call out to the runs DB, of course. But it's just that class that's doing it, not any of this stuff. So there's different ways you can do that. The runs database is one that's used for, or that will be used for most of the officially produced data in Xenon N-ton, at least in the long run. We expect that would be one of the possibilities. There's, of course, another possibility, which is the Rukio catalog. Currently, that is not supported in Strax at all, but maybe that will change at some point, and there will be a new front end where you can find data through the Rukio catalog. Then there are more simple front ends, and the one that you've seen before is the data directory, which is just one directory with lots of folders with data. And every piece of data is one folder in that data directory. So that has a pretty simple job. It just looks, hey, given this key that you passed me, do I have a folder named that? Then I found it, and if not, too bad. We actually have 2 others, and they, like data directory, really relate to one specific way of saving files. So in general, these front ends, they just find the data, and to actually load the data, you have something called a backend. So if you want to load data, just store it on disk, you use the file system backend, and that loads it from a folder with files. That's the one that's, I think, exclusively used at the moment, no matter how you're getting the data. But we do have 2 others. One is the zip file backend, which can load data, which is exactly the same format, except that it's zipped. Now, of course, why would you do that? And not to compress it any further, because it's already compressed. That wouldn't work. But you can, well, maybe if you have some extra compression algorithm or something, but that's not going to be very efficient. You would do this because, for example, you want to transfer maybe 500 folders with data, and the folders are all very small. Maybe you want to transfer them in one go. You can zip them all up and load them like this. Something that we don't currently use. Maybe we don't need to use it. Maybe it'll be important in the future. And finally, there's the S3 backend. So S3 is a protocol, I think it's designed by Amazon, or at least Amazon uses it for a lot of their cloud services. And it's just a protocol, so it can connect to anything that supports the S3 protocol on the server side. And the reason we support that is because at one point Chris experimented with calling grid storage from S3, which apparently some grid sites supported. So that would be a second way of getting to data that's stored on grid besides Rukio, if this was supported by our grid sites and maintained. And all of this is not the case, so it is currently more there as a historical relic, or perhaps as something that we can pick up again later. So for your purposes, you only need to worry about the top three things here. So there's the run database, the data directory, and the file system backend. So the runs database can call out all of these backends, and the data directory just calls out the file system backend. Final one thing, the zip file backend cannot save. So you actually have to zip up the folders yourself. Otherwise it would be a little bit difficult with multiprocessing. If you have 10 processes writing data, that's fine if you have a normal hard drive. If you have 10 processes writing data to one zip file, it's going to be a bit more complicated. Okay, so how does this process work in practice? So let's start with finding data. So you are here and you want peak basics for run 7777. So you ask that to your context, and your context will then create something called a data key. So that will store the run ID, the data type that you're loading, and a very large dictionary containing all of the settings that are relevant to that data type, which is summarized in a hash. So this thing, the data key, is then given to the storage front ends that this context has. Usually there are several. We start with the first. And then several things can happen. It could have the data, and then we consider that in the next slides, and you can start loading it. Or it could say, I actually don't have the data, and then it will raise this thing called data not available. There's several points at which that can happen. So it can happen in the base class of the storage frontend. So that's code that all storage frontends have in common. And that so then happens for generic cases, such as this frontend doesn't take this data type. For example, you may have seen that all of the official Xeno and Xeno data also. Data is split over two folders. There's a raw and a processed folder. The raw folder only contains things like raw records and won't contain like event info. So if you have a front end that just goes to this raw folder, it will say, and you try to load event info, it will immediately raise data not available already here, because it doesn't take that data type and doesn't take it nor provide it. Another thing is that maybe you're trying to write something, but it's read-only, and that also doesn't work. Then you can have front-end specific things. For example, the folder doesn't actually exist if it's some kind of data directory like front-end. In case of a RunDB front-end, would be that this data isn't registered in the RunDB. Of course, when you're writing, things are a bit different. Then if the folder doesn't exist, that's good. Then it can proceed. But there are other problems you can have when you're writing. For example, you have no permission to write. And then you also get this data not available error. There's a few other errors you can get. You will rarely see them. Data exists error could happen when you're trying to write something that exists, but that should be really rare, because when something exists and you try to find it, Strax will give it to you rather than try to write it. And there's data corrupted, which means that, hey, this data is broken and somebody needs to delete it or try to recover it somehow if it's still valuable. Those things will actually raise an exception, so then it will just stop doing anything. Fortunately, they should be rare. Okay, suppose you're in this situation, the data is not available. That's too bad. What will it do? It will go on to the next front end and try to find it there. So let's consider that. Let's consider the case of loading data. So in the next front end, suppose that does have the data. What it will then give is some kind of way of going to a backend, which knows how to actually load the data. Right, so the front end produces a kind of key, which depends on the backend. For example, for a file system backend, which is the only one that really matters at the moment, that's just the folder name. But for S3, it would be some kind of bucket ID. And for a zip file, it would be, well, what's the zip file and what's the file or folder inside that zip file I need to run. But for now, it's just like the folder name of the data. And at this point, the front end's job is done. The data is found. That's the end of that. And the onus of work passes on to the backend. So the backend is in charge of actually loading the data. And it's in case of loading data, it's very simple. It's just going to do that. So it actually produces something that's called a loader, but that's really just an iterator over chunks. It's just something you call next on, or you can for loop over. And that will actually load the data from the disk into the processor or write to you if there's nothing to process. I think then we'll still create a processor. But, yeah. We'll get into the processor in the next few things. That's just the sort of data flow backend. Anyway, backend takes care of actually loading the data, and it knows how to, for example, if it's a file system backend, read this JSON file that's shipped with data to find out, okay, what compressor was used, what data type was used, and how do I then go to the actual files, decompress them, and convert them into a NumPy array. All of data is returned as NumPy arrays inside a Strax chunk object. So we saw that before. That is just a thin wrapper around the array, which says when the data started and when it ended. In earlier versions of Strax, that didn't exist yet. You just had the array, and that was it. Okay, so that's loading data. The slightly more complicated case is when you're saving data, because then you need to record more things of that data. You need to record the metadata, the type, you need to do things in the right way. So then the backend actually delegates that work to another class called a saver, and that is specific to each backend. So the backend then gives it all of the information that's needed, and the saver is then called inside the processor. So whereas a loader was just like some very simple thing that you just iterated over, a saver has many different methods of saving data. That's because depending on how you process, it might happen differently. If you're multiprocessing on several CPUs, one data type, then well, several processes now need to write chunks of data to that one folder. And in that case, for example, you cannot, you don't have all of the metadata in one place because you have different processes processing the data. But in the end, you want everything in one JSON file. Now this is really only relevant for the online processing, but what then happens is the saver, instead of updating the big JSON file, will make little JSON files specific for every folder, as for every chunk file. And at the end, there will be an extra step where these things are combined just to prevent any kind of race condition or having to deal with some kind of file locking for this big JSON file. Okay, so that's saving the data, and the backend goes to delegates the piece of work to a saver, and that then gets dealt with in the processing. Okay. So any questions on this this short intro?
So the storage front end is something that you specify, or you can specify when you're making a context.
Mm-hmm.
I'm assuming everything beyond the front end is kind of by design hidden from the end user. So like you wouldn't be able to specify, yeah, I want to look for this data in this specific location. You sort of do sort of back-end specific arguments. I'm guessing that's largely by design.
Yeah, so the backend was really intended as something that is stateless and doesn't have to be configured. So any sort of initialization arguments to the backend, for a file system backend, that's not relevant, but for S3, you need some kind of initialization keys. Ideally, those will be passed in as part of the key. So whether that actually happens, for S3, I don't remember, but yeah, it's intended to be just a simple thing. You can call that, so you can create your own backend to load some data. There's nothing wrong with that. That might be useful in some circumstances, but yeah, the front end is supposed to take care of finding the data. So it should take care of initializing the right backends for the right data. Okay, I think, Aaron, you also raised your hand.
Yeah, so the front end then use the hashes to also search for the data, right?
Yeah, so this is front end specific actually. So you can do several things because there are at least options in Strax to do a more complicated matching. The simplest matching is just by hash. You just look at all the data you have and you try to find data where the hash matches the hash that you have now. But you can also imagine, you can configure this via the fuzzy loading options that you say, well, I don't really care about this one particular option. So just find me some data where this option has any value, but all of the other options must match. Or where you say, I don't care about this whole plugin. No matter what options were given to it, give me the data that was made. So that is supported, I think, by the data directory. So then it will actually compare, go into the dictionary lineage and load the JSON file of the different directories and start comparing them. It will obviously be slower. I don't think it's supported at the moment by the RunDB, but it was kind of meant for the RunDB, because in the RunDB case, you would do a fancy query that would just immediately return that data. But in the normal case, you're right, it just compares hashes, but it can do more.
Okay, thanks.
Okay. Any other questions? Okay, then let's see if we can apply this this knowledge in practice. So I have here a notebook. Let's see, I should put this one, not the one with the solutions. Right, so it's a notebook. It's running on DALI. And suppose a colleague comes to you and says, oh, I've got these amazing paths of data. Can you load them? Or suppose that you've done some kind of project some time ago and you want to load that data. So here are 4 paths. They're in increasing order of difficulty. Let's see if we can find out how to load these things. So let's see, this is the first path. How are we going to load this? Any suggestions?
Can you hear me?
Yes, I can hear you, Daniel.
Perfect. I guess since you just mentioned it, I would use one of these fuzzy options, since I can see from the name that it is an event info data kind. And so
Yep.
I would use, say, give me whatever event info for whatever setting this hash belongs to.
Okay, so you say we can use the fuzzy loading to get any event info data set. Okay, that's a good idea. Let's first just collect the ideas and then let's see which one we want to work out. Thanks, Daniel.
We'd also check that actually it is one of the storage directories, and if not, add to this context.
Also add it, yeah, good point. Otherwise, it's going to be hard to load it. Okay.
And you also have to check that there's actually a plugin with such kind of data types, right?
So check we actually know the plugin. Yeah. Okay, very good. Thanks. Any other ideas? How would we load this this data?
We have to make sure that whatever context we have loaded will match with the lineage.
Yeah, very, very important. So to check that what we're, the lineage matches our context, right? Because if it matches our context, then our job is a lot easier. Then we can just load it without using any fancy options, etc. Okay, very good. So maybe there's one more thing. If you look at this path, do you notice anything unusual or maybe something familiar?
That it's wonton data because of the naming of the runs.
Yeah, it's wonton data. That's very good. That's right. That's this run. What about this part of the path? Does anybody recognize that?
That's where the data is stored on Dali, isn't it? That's where the
Yeah, that's where the
official
data
permanent
is
location.
stored. Yeah, this is okay. So very good. So this is the point that for this path, this is just the official location where data should be stored. So it might be, if we're lucky, that we don't have to do anything special to load this data. This would just be loaded by default. So all of these checks, we can do them, but they should come out. They might come out positive for this data set. So let's check some of these things. So let's see. Well, event info, I'm pretty sure is there. Let's see what the key is for this data. Right, so the official hash for this data is OR7HQ7. That looks pretty good. So maybe we can just load this data as usual. Let's check whether it's stored. So that looks good. It's just the currently supported hash. It's stored in an official directory, so it actually already finds this. So in this case, loading it's very easy. We can just do get array. I don't know what I'm doing now. Get array, and here we get the data. Okay. So that looks good. Am I sure that actually this file got loaded? What do you think?
Not per se, right? It could also
Maybe
be
if you
from
also
another
have different
content.
file paths where it
Yeah.
will be sooner.
Yeah, exactly. So there's multiple storage front ends registered. Right, so there's a couple. If you look in, so let's go to where the contexts were made. Jelle Aalbers online, you can see that there's actually here the run-db, then there's data directory and data directory. Now, fortunately, this one at least lists Dali, Grande, Jelle Aalbers processed, but perhaps the run-db has something registered that says, oh, you don't go there, go to some other place. So is this a case for concern? What do you think?
No, it shouldn't matter. It should be the same data because the hash is the same.
Exactly. The hash is the same, so it doesn't matter where the data is. We should just be able to load it, and it will always be the same. Of course, you could imagine some hypothetical scenario where somebody has been messing with the data, just opening the files and editing some bytes, etc. So, okay. So what if you really wanted to make sure that you're loading this particular file? How would we do that?
Just make this refer to this only storage.
Exactly, right? So I'm gonna change here this thing to just one data directory. Okay. What do I put here?
Just the path for the event number.
Yeah, so this piece, right? Not this piece.
Yes.
Because this is just the path where all of the data is stored. And you can compare that with what we saw in Straxen. That's also the path that's provided here. If you want to be nice, you can pass here read only equals true, just to avoid writing to this directory. You shouldn't have permissions, but maybe we forgot to set it correctly. You can see it's still stored. So it's really only going to that directory. Very good. What you can also do is you can use a little bit of code. So this is just copied from what's inside Strax. So I'm looping here over the different storage front ends, and I'm trying to actually find that data. And then I'll print it out. Hey, I found it, and otherwise continue. So let's do that. Of course, now it finds it because it's the only front end. Let me load the old context again. It still finds it. Okay. Let's see. Let's also print out the exception when it doesn't find it. Yeah. So it says here, hey, there's a data directory that doesn't accept event info. That's the raw directory, and here we have the file system backend that does find it. So that's good. We loaded this data. Let's move on to path number 2. How are we going to load this? Almost already. Yeah, go ahead.
Can't you head to your the storage, that path?
I add to my storage. What? Sorry.
That path. The
path.
The path.
Yes, exactly. Right. So I'm gonna add storage this path. Okay. Let's see if that works.
You didn't make it the data directory, Jelle.
Oh, okay. So then it might not work. Let's see what happens just for fun. Yeah, find takes no keyword arguments. That's interesting. Okay. I thought it might have been implemented, but I guess not.
I mean, strings have the find method.
Yeah, I'm afraid they do. Yeah.
Which is what's running into here.
Yeah, very good. Thanks, Daryl. So it's a Strax object. Okay. At one point, we had implemented something where you could pass a path and it would turn it into a data directory. But yeah, it's already done. So how did you know this would work?
This will write the previous path then.
You said it would override the previous path?
Yeah, the path 1 that we had before defining.
Well, in this cell, I overrode the variable path, but there's no data.
When you add it to data directory.
Mm-hmm.
I think Aaron's point is that we're getting rid of all of the previously established directories that it looks at.
Yes, that is correct. So I'm assigning this st storage to a new list, and it has just one data directory. If you wanted to, you could also have appended a data directory. But that wouldn't have made sure that this is the only directory that you're loading. So that's why I overwrote it with a new list. So how did we know this would work for this data set?
The hash is still the same.
Bingo, the hash is the same. So I didn't have to first check that. Okay, very good. This was an easy one. Let's try a more difficult one. Path number 3. So will this, okay, well, I don't need to ask if the same, well, okay, let's see, maybe this will work. How would you suggest loading this?
Do we have a plugin which provides external triggers?
Good question. How will we find out if we do have a plugin like that?
just check for any run ID if the data is available or not.
Okay, let's check that. Let's load the original context again, otherwise it won't work. So which run would you like?
It's probably the Anton context which you want to use.
Okay, let's use Anton context. Is stored. Okay. Which run shall we pick? It's quite a lot of runs, right?
7219.
Okay, 7219. Okay, that's this one. Maybe it'll work. Yeah, this can't happen, right? This would be too easy. No, unfortunately, it says no plugin class registered. Okay, so that's actually good. We gave it an informative error message. I was actually hoping we didn't, because then we'd have to check through some other way whether we had such a plugin. And you can do that through the plugin class registry. So here you can see all of the data types which we have registered. You can see whether external triggers is in this. Yeah, but this also works because we were kind enough to add an informative error message here, and it doesn't matter which one you put here. So very correct. Okay, so this doesn't work. What's next?
Then we have just one option. I think we can just go via the interior of load file and just read the buffer, read the bytecode, and then convert it in array, isn't it?
Okay, so you're saying let's go to this folder and let's see what's in there. Okay, we can do that. Okay, so then here there's a JSON file and there's here a binary file, and you're suggesting, hey, let's read this thing and start messing around with it.
Well, you can get the compressor from the JSON file, and then you can just decompress it using that compressor.
Yeah, let's write these things
Exactly.
down. So go to metadata. No, you know what? Let's just do it. Okay. So I want to get this JSON. Right. Let's see what's in here. Oops. Okay. Right. So that's a big JSON. So the compressor was BLOSK. And anything else I need?
The data type.
Data type, exactly. So I've got this here, which is a description of the data type. Otherwise, I can't read it into an NumPy array. So what I can do here is I can do Strax load file. Let's see what that takes. It wants a file name. Okay, I can give it that. Then let's get this. Okay. Oh, okay. I already gave away. We have strax.load file. Of course, you could say, hey, let's try to read this in binary, and let's try to extract this type. But we actually have a function that does that, so that'll make our life a little bit easier. So let's use that strax.load file. But if you want to if we want to redo strax.load file, you can certainly do that. It's not a very difficult function. So you look here. Load file, right? So it's just you open the file, you read it, you call the compressor, and you call numpy from buffer, which changes this raw byte stream that comes out into a numpy array, and that's why you need the data type. So we can at least reuse that part. So let's see, compressor was BLOSK, and then the data type. So I could try to copy it from the JSON. Let's see that. Okay. You could also load the JSON and actually get it that way. Good. Maybe data type. Okay. Let's move this guy up. Error is a directory. Yeah, you probably want to list this file attached to it. It worked. Okay, hooray. This was pretty complicated, but we got the data in the end. So that's good. But is there a better way to do this?
Probably find whoever wrote this external triggers plugin and just copy it to your notebook and register it in your context.
Yeah, that would work. So in case you can't find the person, we could try making it ourselves, right? We could something called external triggers. Then we need to match the version name to the one that was in the JSON.
Well, not per se if you the version name, but you can just use fuzzy options, right?
Yeah, that's possible. Okay, let's try that. So then we just need external triggers, Strax plugin, pass. I want to register it, so I can call st register external triggers.
It
Okay.
probably still needs to be typed, right?
It still needs to detype. Well, let's see what happens. I don't know. Maybe it will, or maybe it will not complain. So then, okay, this is a second thing, so let's do it after this. Okay, let's just put things in the right order. Okay, so I want to replace the storage front end with data directory this. That's not right, right? Don't want this part. Okay. Then let's see. Is stored. Probably want the Anton context, right? Otherwise things might go wrong. Is stored. This run ID. External triggers. Key error. No plugin class register that provides external triggers. Okay, but I have it here.
You registered it for the one-time context.
Very good, thank you. Okay, value error. Depends on not provided. Oh, terrible. Okay. Okay, I have no idea if this will actually work, but I think it's a fun thing to try out. Let's say it depends on raw records. No infer dtype method defined. So you are right, it does need the dtype method. Unfortunately, we already extracted that, so let's just use that. It's not stored. Okay. Is that bad or was that expected?
The default version is 0.0.0, so yes, it is expected.
Yeah. Right, so here you can see that the version is actually 001 and there's this couple of options defined. So I could either now put this into my random plugin or I could use the fuzzy options. Let's use the fuzzy options for this time. Let's see, those are context options. And of course I forgot what they're called. So let's for the show config. So we have fuzzy 4. Tuple of plugin names for which no checks for version providing plugin and config will be performed. That looks pretty good. So let's do that. Okay, and it's supposed to be a tuple. And let's set this to external triggers. It's a tuple of plugin names, right? Okay, good. What did I do wrong here? This is not going to work.
You have to add a comma.
There's a comma, you say? Okay, that's a good point, and we're sure that it's a tuple.
It's probably the camel and snake names or not.
Yeah, so it might have been external underscore triggers, because that's the name of the data type. But it says here that it's supposed to be the name of the plugin. So if the documentation is correct, which isn't always the case, then that part is okay. Something's going wrong. Let me show you when I'm running it. So I set this. Let's do again show config.
That's not how you change the config for a
Bingo.
context.
That's not how you change the config. How else will we do it? Recalling our previous circles.
Set context config.
Bingo. So it's context config. In fact, what I did with the previous statement is that I changed config, which is just the configuration for the data. Right, so it's like the game model, the number of top PNTs, and so on. So I added this thing called fuzzy4, which in this case is harmless. We're going to get a warning about it, but it's not really a problem. So don't call your plugins game model or something. That is very bad for various reasons. Okay, let's see if this works. Option fuzzy4 not taken by any registered plugin. That's interesting. But I changed the context config.
That's what
But
you
the
just
fuzzy,
said, right?
yeah, you're literally just saying that it's going to complain that fuzzy4 is not taken in the plugin configurations.
Bingo, it's the other fuzzy4. Okay, very good. Okay, but it still says false. That's tragic. Okay.
Straxferno version.
Straxon version. So the Straxon version isn't explicitly tracked here. It does actually track the Strax version, but that's just something that isn't really used just for fun. It's tracked. So that's not it. So actually, I mean, I don't know what's happening here. I haven't used this fuzzy4 option for months. I hope this works. And maybe it's what Joran said, that actually we need to do this. That's possible. Then the documentation is wrong. Let's try that. Yeah, that was it. Okay, oh, very good, Joran. You were cleverer than the docs. So it looks like we solved it. Let's see if we can actually load it. Very good. Okay, so this is another way to do it. So rather than going into and messing with the data types and load file directly, you can create a fake plugin and mess with the fuzzy options and then get the array. So maybe this is slightly better, but it's still rather awkward, right? I think there's still a better way. How would I load this data? I don't have this plugin. How am I going to load it?
Maybe it's stupid, but since the storage frontend is the one saying where data are, could it be done out of the context and just creating a storage frontend and saying where the data are, and then the rest is taking care of it?
Okay, that's almost right. So you're on the right track. So there is some component in Strax that knows how to load data. And there's another component, the front end, that takes care of finding data. So in this case, it won't find this data because we don't know how to ask for it. So that's what we did here. We messed around with Strax long enough that eventually Strax asked for this data, and then it did work. So going and getting the front end out of it, that won't help. But there's another part of Strax that knows how to load data without knowing how to find it. So can we address that?
That you somehow directly call the loader.
You can directly call the loader. Yeah, okay. So the loader isn't really a class. The loader is made directly by the backend, but other than that, it's exactly right. So we're going to call the backend directly. Remember, a backend was designed to be something that is done on purpose, sort of. So it's really easy to create. So I'm just going to create a file system backend. And then I'm going to ask for the loader, as Peter said, of this path. Okay. Looks like I'm getting something. So how am I going to get data out of this?
I think you have to specify the data key for the loader that he knows where to. I know the loader. So you need the data key to create a backend key, which you then pass to the loader, right?
Okay, let's these are all good things, but they're part of this this whole story, right? So you have, this is the normal way things happen. So you ask the context makes a data key, that makes a backend key, and that goes to the backend and makes a loader. So that's what we tried here. We just tried messing with the context until it eventually made the right data key, and then the front end found it and everything went all right. What we're doing now is saying, okay, I don't want to mess with all of this stuff. I just want to load the file, the folder, and I already know what the folder is. So sort of the context in the front end, I don't, they're out of a job. I don't want to work with them because I already have this information. So I'm just going to pass the folder name to the backend, and that should work. And in fact, at least it doesn't give an error. It's just that I get this generator object storage backend loader. So how do I get data out of a generator object?
You iterate over it.
We iterate over it. Bingo. Right. So. Okay. Right. So this thing is a Strax chunk. If you actually want to get to the data, here we go. So this is a bit silly. I should probably concatenate these into one thing. So let's see. Let's make a list comprehension. Okay. Here's the data. Okay. So that's a lot easier, right? Than messing with all the options and doing stuff. So you just directly call the backend, give it the path, and that's it. So let's write that out neatly. Loader. In case I only want the first chunk, it's a little easier. I just call next on it. And then I get one chunk.
So this would work whatever the context is.
Yes, the whole context is just bypassed,
Okay.
right? I'm not calling the context here. So, for example, this is Xenon Enton data, right? But it just loads because
Okay.
I'm not referencing any one-ton or Enton context. This is it's just a general way of load me this data. I don't care what's in it.
This only works because we have also the JSON file, right?
Well, let's look here. The only information we used is this path. So
But
this work.
Where the JSON file is within this path, right? I mean,
Exactly.
how does the loader otherwise know which decompression he should use? And
Yes, so that's why we store the JSON file with the data that this data type is provided. If we hadn't stored that JSON file, yeah, then would have been a bit problematic. Then you just have a lot of bytes, but you have no idea what they represent. That would be problematic, yeah. But in other backends, this also works. So if you have right? If you have here the zip file backend or the S3 backend where there is no JSON file, this is stored in some other way, that's fine too. The backend knows how to load the metadata and then how to extract the real data. So we're really directly addressing the part of Strax that knows how to do the specific job we want to do. We just want to load data given a path or maybe an S3 bucket ID or something like that. That's the backend's job. The whole front end and context stuff is stuff that's all nice for the more general case where you don't know the path, but if you already know the path, you can just do this. Okay, so final path. Okay, what would you suggest we try now? We've seen many methods. Which one would you try first?
I mean, this should be very similar to the one we just did. The difference is event info is a pre-registered plugin.
Yeah, that's right.
But it's got a different hash, different lineage hash.
Yeah, right. So the methods we did under 1 and 2 where we just changed the front ends, those are not going to work because it's not a matter of finding the data. It's that this data is not what the context is asking for. So we could either change what the context is asking for. So we could like modify, okay, we don't need to do this step as Daryl pointed out. Already a plugin has been registered, but we'll need to use fuzzy4. We could do that. We could start modifying the files, not modifying them, but just loading them one by one ourselves after extracting the D type from the JSON, etc. Or we could try this trick. Which one do you want to try?
The file system backend is probably the fastest.
Exactly. So this is a very good idea. Whenever you have the path, you can always use this. Unless you want to do, for example, extra processing on the data, then but then you should not be in this this kind of situation that there's some wacky data type. You have no idea what settings they were made with, and you just want to load it. That's okay. But if you want to do extra processing on it, new data types will get created, recording what settings were used. So yeah, if you don't, that's not a good place to be in. So the reason I picked this example is because this is a example where even this does not work. So here it says, hey, I cannot load this data. It was created with Strax 087, but you have Strax 0110. But I just told Janyu that, hey, when he noticed, hey, this is created with a different Strax version. Oh, but this Strax version is only sort of stored for, for fun purposes. It's not really needed. That is true with one exception. If you have a archaeological Strax version, the data format is actually different. So in that case, there's some check in the backend that says you cannot load this data. Okay. However, we have two other methods that are in principle perfectly good. So let's just do one of these. I think the loading. Okay, so the method of changing what Strax is asking for is also not going to help. You're also going to hit this check. Of course, if it's really a completely different format, then it wouldn't help. But in this case, I know that it is a format that I can still read with this load file business. So that I can put here this, and then I go through the same usual steps. Actually, let me just copy this because we saw exactly how this works. So you can load the JSON and then load the file. Okay, and that works, and I can just check that with a little plot. Right, it's just a mini analysis where I'm just passing the events in as an extra data frame. Okay, so this option of actually loading the files individually, that's sort of your last resort option when nothing else works. Maybe the data is corrupted, the metadata is missing, but somebody still whispered in your ear what the metadata compressor and D type were. You could try this. But in almost all cases, this is the method that you want to use. At least just to load data that you cannot get through normal means. Of course, if you're doing regular analysis, you should never be in this situation that you get a path and that you need to know how to load it. You're in the situation where you say, hey, given a context and run in a data type, how to load it. Okay, we're trying to go a little bit beyond regular analysis situations here. This might come up in 2 years, somewhere down the line, and then you know how to deal with it. Okay, any questions on this this exercise we did together? Okay, looks like not. As usual, I'll post the notebook, maybe slightly cleaned up, to the GitHub repo. So then let's get to the questions that you had on the reading. So we have quite a number of files that we went through. So I would just suggest that somebody raise a question, and then we go to that file, and then anybody who has questions on the same file or class could go next. So who wants to start?
This might be more of a sort of meta level question.
Sure.
I found a really inconsistent way of reporting information back to the end user among the various files here.
Mm-hmm.
So the I think the storage front, it's either the storage front end or the storage back end, defines a logging object. There are two lines in the Mongo file that actually call this logging object. They actually try to log. There's one other thing in common.py that uses the warnings package. In the files file, all of the information back to the front end is just dumped to standard out. And then I think most of the, and then there's a large amount of information is passed through raising exceptions.
Yeah.
So like I can see the exceptions because that, you know, breaks whatever code is trying to call it. But then we have three different other ways of sort of non-breaking communication to the front end. Because we have, you know, logging, which nothing uses. Then there's warnings.warn, which there's one thing uses, and then there's print. It just seems like a really inconsistent way of front-end communication. I'm not sure if that was by design or just by, I guess, feature creep.
No, it's a fair point, Daryl. So there are many ways of communicating with the user, and as you say, exceptions are special because you can catch them and then do something with them. And the most important exceptions we saw, so that was this data not available exception that's raised in the various places and then caught, and then the message is maybe changed a little bit. But I think your comment was mostly about the non-breaking ones. So the logging, a problem with the login module is, so I don't really like it personally, but I as you see, I've used it in some places. A problem is that you cannot use it in objects that are forked, because then apparently the logging finds it necessary to create some thread log objects, and when you fork them, then it gets into trouble. So when you get to here, this saver object, which, as I mentioned, is also for like forking, saving in different processes, you cannot use this logger information. So I think maybe some of these guys have a logger, but this guy cannot have a logger. Then things will go wrong. So then you could say, hey, but if you can't use logger for this, then why are you using it here? Maybe you should only use just the warnings module. We could use that. The logging module does have some advantages, but
There's one of the things in the file saver. If there's already stuff existing in the path it's trying to write to, it's, oh hey, by the way, I'm deleting data. You know, just
this one
standard out. That just that just feels like rubbing your hand the wrong way on a shark. I mean, you can, but that just, I mean, that just seems like a recipe for disaster.
Yeah. So that here is really that I would have liked to use the logger, and maybe I should here raise a warning message instead. I think that would be better. I don't, at this point, want to prompt the user for an extra confirmation. That's already happened in earlier things. The file saver's job, that's already a very low level thing, right? So in our little hierarchy, it's already here. The question whether you want to overwrite data should be dealt with by this front end, because this front end is getting the request, hey, I'd like this data, and the context has an option for this saying allow overwrite, yes or no. And I think by default it is false, but we can check. Maybe it's true, but allow overwrites. This is a front-end option, actually. Sorry, it's called overrides. Yeah, here, overrides. So by default, it only overrides if the data is incomplete or broken. You can also just change that to always, but yeah, why would you override data if it already exists? Because Strax will never ask it to write data if it's already there. It will just try to load it. So I don't think that case will happen. But anyway,
yeah, this makes sense.
Yep.
But considering that we so I'm not sure if this edge case is sort of quote unquote easily possible, but you just showed us a way to completely bypass the front end to load data.
Yeah.
If there's a way where you can bypass the front end to also save data, and it just gives you a print statement. Oh, hey, by the way, you're deleting an already existing file.
Yeah.
I'm thinking here of the well-meaning but somehow not fully informed user who found this piece of code somewhere and is trying to do it to save this interesting file that they found, and end up overwriting some official file in a way that isn't it's basically now the bytes on disk are gobbled.
Yeah, no, that's a fair point. So we should maybe for extra security add an option here, override, which is by default false and is only set true if you call it through the official method. And I guess a similar protection would apply to where you go to io.py to save file, where it just opens the file and it will actually just clobber it. Yeah, we could build in a few extra checks there. Yeah, good point.
I do agree, though. At some point, at some point, there's a limit to the protections that are reasonable to implement and the protections you can implement. And I'm not exactly sure where the line is and where exactly we are relative to that line. But it was just a thought that I had.
Yeah, no, thanks for that. That's good to hear. Okay, let's see, Johan, I think you raised your hand. You had a question on a similar point, or?
Oh no, what I posted in the chat was just that I also saw that a lot of times there's actually exceptions accepted as something, and then nothing is actually being done with that exception. It appears, but I actually had another question because I don't think this is
okay.
that interesting.
Just on that point, so exceptions can be used as a way of signaling within a program, and that is often how it's used here in Strax. So you can see that in the context .py. So let's see where an exception is caught, and not in this one here. Here. So for example, when we're this code we haven't read yet. Let's not do that. Let's go to. Okay, so in this case, here it's re-raised. Let's go to one where it's not re-raised. Yeah, this is the one I was after. So when you're getting metadata or when you're finding data, it's looping over the different front ends. And the way for a front end to signal that it doesn't have the data is to raise the exception. So then we're just, this is completely normal behavior, and it doesn't mean that we need to raise a warning or something. We do a debug in case somebody wants to look at that.
My small question about this was that the ASE is not actually used.
Oh, that's that's true. Yeah, that you can remove. Okay.
But that's not so relevant. Now, the other question I had is actually about the runs database. So we actually, you already saw this in the pull request. We actually, as you say, indeed register stuff before we actually start writing the data out. Is it something we desire that we actually update our runsdb with stuff that hasn't happened yet?
No, that's not desired, and it's an artifact of the way these are designed. This thing is designed. So the registration happens by the front end. So the front end is the guy that says, okay, you want this data? We don't have it. Okay, we're going to write it, and I know how to access the rundb because that's the rundb front end. But the front end never receives a call when the data is done. the way it works is that this thing creates a saver and that's then handed off to a processor and then data flows through it. But there's never a place in Strax where we're calling back to the front end and say, hey, now we're done, so let's update the registration. So there's a few ways around that. We could build in such a hook, or in the script where you're calling Strax, so boot Strax in this case, you would update the registration after the fact outside Strax. So part of the reason this is somewhat embryonic, this whole registration business, is that I think at least at one point we weren't really sure if we want Strax to be able to do this, or if we want to call out, for example, to Utilix, which should take care of that, or to RunDB API or something like that.
Okay.
Okay, but yeah, definitely things that we can improve there. Okay. Right, anyone else has a question on, I think we're jumping over very many different files, so any question that you noted is fine. Right, just putting up the reading in case that jolts anyone's memory. Any more questions? Storage front end, back end, storage system. Okay, let's see if we went through all of the study questions. So I went through this in the intro. And this last one we also did. Okay, so which part of the storage systems would you need to change to implement the following? All right, so suppose I want to change and I want to implement the Rukio catalog, that it calls out to the Rukio catalog to see where our data is. What would I change in Strax?
That's a new storage front end, right?
Exactly. So it's a new storage front end. But you might not be done then. So if the Rukio catalog stores actual file locations, and that would be in the ordinary format, then you'd be done. However, Rukio stores things that are mostly on different hosts, and if even if they are on the same host, they're stored in some other file format. Rather, the file format's the same, but the files are ordered in a funny way. So probably there's more work involved. But at least if you support new catalog, exactly you want to do a front end. Okay. So how would you add, suppose you want to go back to root trees. You want to store data in root trees. How are you going to do that?
It's a trick question. You do not do that.
Very good, Daniel. That must be the answer. Yeah. Okay, but suppose that you do it for an April Fool's joke or something. How would you do it?
I think you would add it to the compressors known to Strax and then just specify it in your plugins.
Ah, that's a nice creative way to do it. I think I would definitely do that if it's an April Fool's joke, because nobody will notice it. And then suddenly the data will get stored as root files and nobody will see it. Yeah, that's a great idea. There might be a more user-friendly, no, not user-friendly. The user doesn't care. So what's sort of a more neat and official way of doing it? Or maybe this is the official way.
New storage front ends and back end, or I guess there'd be more of a storage back end that can read and write to root files.
Yeah. So I'd start with making a new backend. I'd probably store the metadata in a T-string or something like it was for packs, and then make just a single tree for all of the objects, and then that backend wouldn't need to call out to to io.py or anything else. Do I need to change anything in one of the front ends to enable this? What if I want to make sure that all of the data from now on gets written as root files? How do I change that?
You'd have to change the default file front end / backend.
Yeah, you have to change the default backend. Okay, let's look. So where should I look? What file?
This is a context option, isn't it? When you're making a context, you specify which storage systems you're using.
Yeah, so when you have here an option in context.py storage, and that's done in context.py. There you specify the different storage options. But these are storage front ends. So we could make a new front end that only saves root files. But what if I want to change the behavior of this front end? Where should I edit this? Okay, let's go to the file that has that front end.
You see the default backend there is a file system backend.
Yeah, you see here there's only one backend. So I can replace this with my root file backend, and then I'm sure somebody will notice my joke because all of the Xenon data will suddenly become unreadable. Because then whenever the data directory gets asked for any data, what will it do? Right, this is the case for all storage front ends, so I can look here in the find method. Right, so this happens when you're finding data. What it will do is it calls self_find. Okay, so that's implemented again here. Okay, right. So this is in the front end. So yeah, it will. Okay, so for this directory there is only one backend. I was thinking of the RunDB frontend because this frontend only has one backend. It's just a directory with data. So why would you ever need more than one backend? In the RunDB, that frontend has multiple backends, right? If you look at our little graph, that can go to more than one thing. So then I would go to the RunDB, which wasn't part of the reading. So I'll just mention it briefly. Here, so here we have a backends list. So here I could add then my root file backend. You can see that actually the S3 backend is currently still active. So if somebody puts in data in the RunDB where it says, hey, this came from S3, then we should just be able to load it. The way, by the way, the RunDB decides between backends, this is optional only for those interested, is that there is a field called protocol. For every piece of data, let's just go to the DQ website. Okay, need to log in again. Okay. Right, so for every piece of data, let's go to the JSON. Right, that says here protocol file system backend. So that is actually what's used by the RunDB frontend to know which backend to call. And then the location here gives backend specific information, which in this case is just a folder name. So if I have added this root file backend, I would change here you can add here a thing with a different protocol. Probably has still the same location, but then with .root attached or something. Okay, so come next April, you all know what to do. Let's see. Okay, and let's see. What was this? Support a different scheme of file organization in which different runs are more. Okay, we already covered this. This is what Rukio does to our files. Rukio scatters our files in different directories based on their checksum. So one open problem is how is Strax going to access that? Currently, you have to actually download data out of Rukio to to get it, but there might be a way of modifying Strax so that it can access Lukio. I think Luca was trying to work on that. All right, so I think that covers the study questions. Anyone else thought of any question on the storage system? If not, I'll just give you a brief preview for next week and just a reminder of where we are. So we have now finished the outer circles of our Straxferno course, and this circle was already kind of on the boundary. Remember that river that enclosed the inner city of this or something. So those were the things that you might at some point see as an analyst. Some things you'll definitely see, like the plugins, the algorithms. The context is something that you interact with. The storage system you don't usually interact with, but you could have cases like we just saw where somebody just gives you a folder and you need to load that data. So things are going to get less and less relevant for analysts and more relevant, or well, at least equally relevant for people who want to develop and understand what's going on inside Strax. So the next 4 circles are all about this. So we're going to study how plugins work on the inside, how they pass data around, how they interact with the processor object, which is actually in charge of fulfilling your request for data in case it hasn't been made yet. We'll see how this thing is set up. So how does this matching of this big lineage object to the different plugins work? How do Strax know which things need to be reprocessed, which things not, and when to create a new plugin and give it the right options? And finally, in the final circle, we'll look into how the data flow actually works. There's something called a mailbox, which controls the data flow between the various threads and processes in Strax. So none of these things are things that as an analyst you should ever encounter. The only reason you might encounter them if there's some error, but I'm nonetheless hoping that some of you will be willing to learn about it so that you can maybe add new features or repair problems that are associated with it. But it's definitely a bit of a different focus than the first 5 lectures or circles that you had now, which were about sort of training expert analysts. This is really for training developers and maintainers. But feel free to attend even if you don't currently aspire to such a role, are just curious or something. So specifically next week, what we'll start doing is we'll start looking at chunks and plugins in more detail. So we'll read the chunk class and the plugin class, except for 2 methods, which we'll focus on next week. And we'll look at how the different plugins are implemented. So I'll try to add a few study questions, but really this is, the idea is that you bring your own questions and we discuss them, or else we don't have much to do. Okay, so that's next time, chunks and plugins. That's, I think, all I had for today. Anyone else has a question that they just thought of, or some comment? Or... Looks like not. So then let's talk again next week. Bye.
See you next week.
Bye.
Thank you, Jelle.
Ciao.
Thank you.
Bye bye.
Thank you. Bye.